Thank you, and welcome back to the APN Plastics Conference, and welcome to everyone who has joined here. Just for recap, this morning we had very interesting discussions of presentations, one by Nikhil Valapan from Frost & Sullivan, where he was talking about slippery coatings for packaging materials, and especially for high value add additives, where he sees the high growth potentials and also many advantages using those slippery coatings for packaging, like reduced cost and reduced wastage and less interaction with the chemicals inside the packaging. So after that, we had a talk from Simon Clark from Clariant on liquid vehicle technology, which seems to have no disadvantages, but many advantages, like a uniform color and no heat history and very improved yield and very shiny colors with this technology, the liquid vehicle technology. So with that, we are coming to the afternoon session, where we'll have two talks. The first one by Mr. Nalin Amanugama, who is talking about bottling technologies, following by Madam Sok Meng Chan from Clariant Singapore, who will talk about chemical coating solutions. So let me introduce you to Mr. Nalin Amanugama. So after his graduation in business administration, he went straight into the compressed air industry and never looked back since then. So he worked in that industry, then he started his own company in that business, and with that he got in contact with Boge Kompressoren, which he found so appealing that he joined in 2008. And now he is the general manager for Asia Pacific for Boge Kompressoren. Let's welcome Mr. Nalin.
Good afternoon. I will be my part of my topic will be compressed air, which is related to bottling techniques. So preform and production of bottles and so on. So just a little bit of market information. If you see this picture shows a little bit of old statistics. But you can see since 1980s, the PET has become a future for bottling. And if you look at the latest records since 2009 to 2016, the market volume is about 16.8 million tons. What business is PET? So most of you are in the PET industry or supplying of material and so on, going on like that. And it is growing. The compressed air demand for this industry is also growing by 2.4% since 2009 to 2016. And the best part is 32% of the total global PET business is from Southeast Asia. So that's where we are, and it's a growing market, and it's a developing market for PET requirements in Asia Pacific. So mainly the PET bottles are used for all kind of packaging, like fruit drinks or other soft drinks and so on, and other beverages, some chemicals and some cooking requirement, cooking drink liquids and stuff like that, because PET bottles are lighter and it's easy to handle and it's easy to be recycled and things like that. So it's a growing and a demanding market. When it comes to manufacturing, there are a lot of PET bottle manufacturing processes. You get single stage machines, which comes like you manufacture the preform, then you blow the bottle, and then it goes to the filling all the way in one line. So this is one kind of industry that you have. Some of the big manufacturers of such machines are from ASB and Nissi and stuff like that. And you can go up to about 9,000 bottles per hour of manufacturing. So, which needs pressure of high pressure compressed air of 35 bar basically. And for the low pressure, there is a low pressure requirement as well for the pneumatics to work, so that your plant will do the job. So there are two kinds of pressure applications, and since couple of years long, the 40 bar or the 35 bar pressure is been just blown and sent it out to the atmosphere. But with the growing demand of energy bills rising up, all this has created, there was a requirement for recovery of this energy or the compressed air that is blown out to the atmosphere. So since 5-6 years back, manufacturers of these machines started building compressed air recovery systems, ASR, ARS you call it. So what you do is, when you have a rotary system or a linear system, it doesn't matter. So the final product is blown at 35 bar, but that energy is the compressed air that is blown at 35 bar is recovered to do a pre-blowing to the previous bottle that is coming in a line. I hope you can understand it because you recover the, I don't have a slide to do that, but maybe on the next slide I will show you. This is the final blowing, but it will take the pressure back to the bottle that is before to blow at a lower pressure first, and that air again will be used to blow to the bottle before to blow at a lower pressure again. So it will be blown, the final product is blown in 3 stages. So you can recover the compressed air without sending it back to the atmosphere. Then of course you can use the balance, after the 3rd stage, the 4th level, it goes back to another tank and it will be used as pneumatic air for 7-8 bar requirement. So this is a better way of blowing bottles or using compressed air rather than sending it outside after you blow at 35 bar. So there are machines that are built now with air recovery systems, which you need to look at when you are deciding on a plant. All right. So what we would also recommend is the conventional way of doing packaging or blowing PET bottles was you use a big compressor which had from zero it sucks atmospheric air and blow it to pressurize it to 40 bar, and you use that compressed air to blow the bottles. But the general norm is like when you start manufacturing bottles, you are not going to manufacture the same kind of bottles every day or the same size. You will keep on changing the bottle volume. Then you will also change the speed depending on your demand. So when you do a variation of compressed air requirement, then it makes no sense for you to have a very big machine that can produce the maximum at one time and utilize halfway or 50% or 70%. So it's better to have a modular system to produce bottles rather than having a one big system that does everything in once. So what we come out with a new concept that you can have a modular type system where you have the compressors have a low pressure system, then it will be boosted to whatever the pressure that you need, whether you want 40 bar or 35 bar or 26 bar, because depending on the kind of bottle that you blow and the design of it that you need, you can blow it at from 22 bar all the way to 35 bar pressures. So you can have a pre-pressure compressor system, then you can have a booster system where you can boost it to whatever the pressure that you need. So before you go into a production plant, what you need is to ask yourself, or design part of it, you need to ask these questions like, what is the low pressure requirement, or whether you want single stage or two stage blowing. Then what would be the air requirements? So this is the biggest question, because the general norm, a lot of consultants or the bottle manufacturers will say, I need oil-free air. When you say oil-free, you have to have a benchmark, what you mean by oil-free. Because there's technically oil-free compressed air, or you can get an oil-free compressor system. Oil-free compressor system only means that during the compression stage, you don't use oil. But the question, what happens is, what is happening here in the atmosphere? Because there are, in every plant, you get generators or injection molding machines or whatever the machines that produce hydrocarbons going into this atmosphere, like even your vehicles and even places like in Bangkok or around Bangkok, a lot of cars are emitting a lot of hydrocarbons into the atmosphere, unburned fuel. So all this is in atmosphere. So if you have 1 milligram of hydrocarbons in atmosphere, when you compress it to 35 bar, that means you are going to put 36 meter cubes of ambient air into a tank of 1 meter cube, for example. So that means if you have 1 milligram of hydrocarbons in atmosphere in a 1 meter cube, in compressed air you will have 36 grams of hydrocarbons. So it doesn't matter whether the oil came from the compressor or not, because you had it in the atmosphere. So that's very important. Although you have an oil-free compressor, it doesn't mean that your product is going to get contaminated. So you need to look at the whole process. What is the pressure that you need? What is the volume requirement that you need to produce? How much of compressed air you need? All this information has to be discussed. I think you will get a copy of this presentation, so I don't need to go from each question to question, so you can think of it later on as well. So to determine what is the compressed air requirement is also very important, because most of the time if you design the compressor to be too big, end of the day you will waste energy. If you decide the compressor to be too small, you can't do the production the way you want. And that means less efficiency, so which you are going to lose again. If you don't have the equation, here we have the equation what all the bottling manufacturers use. So you can use this calculation to determine the compressed air requirement. And also you can see there is a safety factor that we have put, because in case of a preform burst, you're going to lose compressed air. And in case of there are leakages in the plant, if you don't maintain it, you lose compressed air. So for compensating of all these factors, you need to at least put additional 10% of compressed air into the plant when you are deciding, so that you don't have a starvation when you are doing the production. The next stage, as I told you, what is the cleanness of compressed air that you need, has to be defined according to the ISO 8573 standards. So if you just, without going blindly saying oil-free, it doesn't have oil-free in the sense it's not 100%, it has a little bit of hydrocarbons, how much you do of purification, there's a little bit of hydrocarbons in the air. But what we need to do is to have less than what we have in the ambient. Then that is good enough. So you need to look at what is the solid particles that you need, that you can allow, what is the water content, what is the oil content, and whether you need sterile or not. Because there are a lot of microorganisms in the atmosphere that is also going to come in compressed air. And especially if you're having what we call it hot filling, like if you do the production of the bottle and immediately if you're filling it up, you need to make sure that there's nothing inside the bottle when you fill up your beverage or whatever the final food product that you're going to fill it in. So this you need to take care. So generally the requirement is for oil is ISO class 1. The water can be 3 to 4 because it can you have to be very sure about what is the clarity of the bottle that you get, because if you have a lot of moisture in it, your bottle will get discolored, so the product will not be clear as what it should be. And solid particles also important, because when you blow it at a higher pressure, if you have solid particles, it can go to get stuck into the body because it's very hot. So then it's not only the compressors, you need to think of what is the purification equipment that you need downstream. So for particle removing, you need coaxial filters. Then you have to use either a refrigerant dryer system or a absorption dryer system, depending on the dew point that you need of the compressed air or the moisture content of it. Then also you need to have absorbers, carbon absorbers, so that it can take off the hydrocarbons in compressed air, and also the smell. If you have any odor in hydrocarbon smells or whatever the smells that are there, it gets absorbed by this material. Then of course you will need, at the last stage, you need the sterile filters, but it's up to you whether you are going to use a sterile filter or not, because when a bottle is blown at 200 over degrees, it will get all the microorganisms get killed. But it depends end of the day whether you need to use it or not, depending on the kind of beverage that you are going to fill it up. Yeah. So when you have a basic modular system, you have a pre-pressure compressor system which will go through filtration and purification of the equipment. It could be an oil-free screw compressor or an oil-lubricated machine, depending on your requirement. Then it goes to a low-pressure compressed air tanks, so that you can use this low pressure for your pneumatic applications in the other area of the factory as well. That compressor can be a variable speed driven compressor as well, so that it produces or runs based on the demand in the factory. Then at the second stage, you can have the high pressure series of boosting, where you can have a modular system again. You can have 1 booster or 10 boosters, or basically it's 4 for each sector. Then these boosters will start and stop only based on the demand. So it's one by one, it will start and stop, and depending on your demand, it will run. So you save energy widely, so that you don't experience unnecessary electrical usage. So end of the day, depending on your production, only the machines will run. So here we have you can choose whether you want oil-free compressed air from the compressor itself, or you can use lubricated compressors and do the purification, so that you will eliminate everything that is in compressed air. So you have 2 options of that, because generally oil-free compressed air systems are very nearly 2 times or 3 times the price of oil lubricated system. But if you use purification systems, you can recover, or your investment will be much, much lesser. And also the other advantage is, like, in case of a failure in one of the equipment, you can still run part of your production. You don't have to depend on one big plant because it's a modular system. Yeah. So some will need special requirements, like you need water cooling systems if you need for cooling, and skid mounting systems. All these are available in the market now with modular systems. So you don't have to worry about how you design your plant and stuff like that. You just need to give the suppliers the requirement, and then they will create the modular systems that is required. So this is just a sample of a modular system. What was designed with a very smaller capacity range. So you can see it's a screw compressor mounted on a tank with a refrigerant dryer system. So it will go through a set of filtration, then it goes to a pressure boosting system, go to 35 bar, and here we have a 35 bar tank or a 36 bar tank. Then that also been cooled with the water cooling system, and then it goes to a high pressure drying system so that you don't have any moisture in the compressed air, and then it goes through a final particle filter and goes to the system. So here we can have a sterile filtration if you require, with a bypass system of sterilizing the filter time to time with steam, so that you have a perfect microorganism free compressed air. Yeah. So this is a little bit a bigger system, which is producing designed for 45 degrees Celsius ambient, like in the Middle Eastern areas. So it produces 1,500 liters per minute of 35 bar compressed air. So here again it goes to the same filtration processes and tanks and going to the system where you can use it. So what happens in a high ambient situation or compressed air production, you can see during different stage of compression the temperature rises up. You can see at the boosting stages it will rise the temperature to 80 degrees. So most of the time 80 degrees is not good for your production or your distribution system. So we can bring down the temperatures using aftercoolers as well as refrigerant cycles, so that it can be at a usable temperature levels. But of course, when you're blowing PET bottles, of course you can afford to have higher temperature, because anyway the bottles preforms are heated during the process. So on a bigger system, again it's the same. These are just sample photographs for you to understand the modular system. So here we have, you can start from the compressed air demand, if you have from 1.5 meter cubes up to 18 meter cubes, you can have a basic fixed standard system with two-stage compression, and the pre-pressure compressor has to be 10 to 5 bar pre-pressure for the boosters. You can have frequency control machines so that you can have a modular operating system where you can save some energy. Then you have fridge dryers or absorption dryers to take off the moisture from compressed air that you need. And if you want class 1, air quality in the compressed air, you have to have absorber, because like I said earlier, you can have the total oil-free compressed air system, but if you have 1 milligram of hydrocarbons outside in the atmosphere, it goes into the compressed air and it becomes much more higher volume. So actually on an oil lubricated compressor, the oil content in compressed air will be 3 milligrams per meter cube. But if you have 1 milligram outside on oil-free system, you will have 10 times more. Because during compression, what you do is you make the bigger volume into a smaller volume. So that 10 bar pressurizing means it puts 11 atmospherics to make 10 bar pressure. So on an oil lubricated screw compressor system, you have a built-in separation element, oil separating element, which will capture all the oil inside and only let 3 milligrams to go out. But on oil-free system, there is no separation element inside. So whatever that was in the atmosphere, it will be 10 times in the system itself. And worst scenario is you get big piston type compressors which are oil free, and those will pressurize from 0 atmosphere to 35 bar. That means 36 times of the volume. So on an oil free piston system, you get 36 times of oil what is in the atmosphere. On a booster system, you can only add 10 times or 11 times. So that's the difference. So it's easy to purify from a booster system the oil content rather than on a 0 to 35 bar pressurizing system which was earlier used in the market. So since couple of years back, since 2012, I think everybody started talking about class 0 for oil. So class 0, to achieve class 0, it's not possible with any compressor in the market because the atmosphere definitely has more than that. So there's another method where we can use a catalyzer which has a certain material that will break the hydrocarbon chain into water and carbon monoxide. So those catalyzers are also available in high pressure versions as well, up to 45 bar. So you can use a catalyzer to break the hydrocarbon chain, the oil chain, into water and carbon monoxide. So it produces pure distilled water end of the day. So as a byproduct. So all the water, all the hydrocarbons will be broken and will no longer be in the compressed air. But still again, ISO class 0 standard, you still have 0.002 milligrams of hydrocarbons in per meter cube. So it's not 100% anyway. So here we go, a schematic on that. So you can, it's very complex when you look at it, I guess. So the compressed air system, then it goes to few stages of compression. First stage, second stage, and then third stage of compression. So the flexible solutions, when you have it, it depends on the location of production. Most of the big machines will have a problem of high altitudes. So it doesn't matter when you have modular systems. It's easy to calculate for high ambient, high elevations as well. And also for high ambient conditions, you can create machines. It's cheaper, more economical to make smaller compressors suitable for high ambient temperatures. Because every time when you have a high ambient situation or a high altitude situation, the compressors has to be nearly double the size. So when you have a very big system as a one compressor, then you have to have a room this big to house a small compressor or 45 kilowatt compressor. So, but when you have a modular system, you might need half of the floor space because you can multiply put it on one on top of the other, and you can have different structures to cater them. And any capacity can be met with multiple compressors rather than one, because every time you have one system, one compressor, you need to have a backup. So that means double your space and double the investment. Here you can have only maybe 1/10 of your system as a spare, and it's more economical. So it's less energy consuming because it's 4-stage compression, not from one to, it's easier way of compression. Maintenance wise, it's much cheaper because if, like I have seen in some of the countries like Indonesia, and partly in Thailand as well, they use the modular systems, and what they do is rather than doing all the maintenance or overhaul of a system, they just take out a small piece and throw it away and put a new one, which gives only half an hour or half a day for a job. And it's much more economical to throw away a smaller component and replace the entire new system, because then you get another year of warranty and stuff like that. So it's much more economical way of doing it. And when it comes to compressed air, the bigger machines are of course very noisy, but the modular systems are much more quiet, and you don't need special foundations, or you don't need special rooms for installation and things like that. Less vibration, all the pollution controls, everything can be met. And it's a heavy duty designs, so you can run 24/7. There's no problem. The components have a longer lifetime, and also it's easy to replace a component because it's smaller and easy to handle. No contamination. You can get it in water-cooled or air-cooled versions. The machines don't depend on atmospheric conditions and stuff like that, because if you have proper filtration systems installed, you can eliminate all the harm, hydrocarbons and stuff like that is in the system as well. So this is a modular design installation. This is an oil-free system, totally oil-free. So you can see the pre-pressure compressors and also the boosting compressors, totally oil-free from the compressor itself, if that was a requirement. And it's frequency controlled, and starting and stopping is depending on the demand, so there's a lot of energy saving as well. Yeah, so I'm not really sure whether I ran it very fast. So if you have any questions, please feel free to throw it at me, so that I think we have another 10 minutes, I think.
Thank you, Nalin. Any questions from the floor? Maybe just let me start then. One. We heard before on the option on the coding for the no slip. So is there any way that this sort of coding for no slip can be implemented in these sort of lines, so that there is a coding system can be implemented?
Coding?
Oh, you were not there.
I was not
okay,
there.
okay. So basically, before they were saying that no slip coding could reduce or could improve the usage of the materials. You can flow out easier whatever's in the bottles, for example. So that is done by a coating of a no slip coating. So that coating is inside bottles or whatever container.
Okay.
So then whatever's inside can go out easier and without residue.
Okay.
So is that a possibility to implement this sort of coating, no-slip coating inside this sort of system?
In the sense, like most of the bottling systems, if you do have, like, if you have two stage of producing bottles, Like a lot of industries will produce the preform somewhere else, then they do the bottle somewhere else, and the filling goes at the second stage or the third stage. So when you do have systems like that, anyway to do the cleaning with such material, you need compressed air and a washing system. So
then
compressed air is always required for every process down the line. So it's really important that the compressed air don't have any residues or contamination, or else whatever the chemicals that you use or the water, how good the water that can be used for cleaning or the steam, everything gets spoiled again if you have bad compressed air. So it's very important the compressed air to be taken care.
Okay. Yeah. So basically, if it's a modular, if it's a system where you have one part where you have the bottle making, the other one filling, in between you could have a system where you can do a coating inside for this sort of like, let's say, no-slip coating, for example.
Yeah. Everything, for every process you need compressed air.
Okay.
Basically.
Okay. Questions?
I have a question.
Yeah.
Okay.
You see, the raw material design is getting more and more advanced. Instead of using a PET, maybe they are using a different material. Will that affect the pressure of the compressed air which is needed in the final stage? You were mentioning 30 bar. How about if changing from one material to another? Is this 30 bar still the standard?
No. Because now also we see that depending on the material, the requirement for the pressure is changing. So it's not only the material, it's based on the design of the packaging material as well.
Okay.
So it depends on what kind of packaging material, what kind of a clarity that you need, what's the thickness on final product. So based on that, the pressure is changing. So if you can reduce the pressure with a different material, you save a lot of energy. Because every 1 bar pressure that you reduce, you save 7% of energy
Okay.
that is used. So it's the other way around. More you increase the pressure, you put 7% more energy.
Okay.
Doing
Maybe later I will ask further question after I finish my presentation. See how we can work together in the industry.
For sure.
Yeah,
So
to help
if there's a
the end
material
customer.
that could produce better, I think it will save the industry a lot of money.
Okay.
Because compressed air is the biggest energy consuming devices that any factory will have for packaging.
You mentioned that the modular system has big advantages, is autonomous and so on. But at the end, you are looking at cost per bottle. How much does it cost? So is the modular system still cost effective versus a very big machine with very high throughput?
Yes, of course.
Still?
It's still.
Because normally for large volume, high throughput, then the scale will take over. So then you would have lower cost actually for a large system. But for your system, you're saying the modular system actually is more cost advantage than the big system.
Just for example, if you look at a 45 kilowatt compressor, one single piece compressor, every year to do wear maintenance, just to clean the top and clean the system, cost about $45,000 per service. But if you take one of the modules and throw it away and put it back, it costs you only $2,000.
Okay. Okay.
Yeah.
So, no more questions. So then we'll go on to the next speaker.
Thank you.
Thank you. Thank you very much. So let me introduce Madam Sok Meng Chan. She is head of the product management from Clariant, and she's working on chemical foaming solutions. She's talking about chemical foaming solutions. So she's holder of MSc in Advanced Materials Technology, and she has more than 25 years experience in plastics industry, like polyolefin company. She's worked in Total, BASF, and so on.
Good afternoon, everybody. Thank you, Mark, for your introduction. I think it's very challenging to be last speaker of the day. After lunch, maybe now it's the tea break time. So anyway, I will try my best to keep you awake to share with you this technology from Clarion. So this is something about chemical foaming agent. The topic is lighten up packaging. So I'm based in Singapore. I've been in the plastic industry more than 25 years. So being in the resin industry and also the chemical industry for plastic applications. Okay. Let me cover the content which I'm going to talk about today. First, I will talk about the mega trends and what are the implications. And next, I will talk about sustainable solutions in packaging, which is the main topic of the product we are going to talk about. It's called Hydrocerol. And then next, I will talk about what are the benefits of chemical foaming additive and the partners in sustainability, and I will end up with a summary. So next, I will talk about mega trends and their implications. So we all know that there are increased population and urbanization. A section of some country, the birth rate is reducing, but for some countries like India, Philippines, the birth rate is increasing. So the world population is growing to more than 9 billion by 2050. And what does it mean? Let me see the pointer whether it's working. So there's emerging class of populations and buying power. So the buying power and wealth in the emerging countries are growing. We cannot deny this. So example, China, followed by India, and also Philippines in Southeast Asia and Vietnam. So the buying power has been increasing. And there are expectation on higher quality, and also the requirement of the quality is getting higher and higher. And people are starting to talk about more on the brand. They are going for branded products. And hence, there's need for product R&D and increase speed to market, because people want to have new things faster and faster. They want to have a changing new products more regularly than before. So this will lead to environmental issues and resource scarcity. So all this topic is not new to everyone. Climate change, biodiversity, water supply, and waste generation is a result of higher world populations. So because of this, there's high demand for resources. So we keep talking about green, we have higher energy consumption, water consumption, and renewable food. All this topic is not new anymore. It's getting more and more. So next, I will talk about packaging needs. As a consumer, we use packaging, and especially the growing middle class. What they want is they are looking into visual appeal, and international and local brands, they are looking for product differentiation. Example, Unilever, P&G, L'Oreal, and also the brand owners in China. They are catching up. They are talking about visual appeal. This is through all the experience we have in Clarion. We have been working with brand owners, helping them to do color trending, what is coming up next. So they are very curious to work with us. We have a department called ColorWorks. This is the department who interact a lot with the brand owners. And then we have sustainable material needs. So this is in terms of recycling has to be easy. No environmental impact, and people are talking more and more on natural materials. And for the material and also the process has to be easy during production, and also transportation and handling, and lower carbon footprint. Of course, cost effectiveness is also one of the key topics. And I have just mentioned speed to market to meet consumer needs is getting more and more important. So in Clarion, we are looking into the future. We listen to the customer, voice of the customer. We take all this into consideration: aging population, emerging market need, changing lifestyle of the consumer, ecology and convenience. So we are doing a lot of product development to address the market need. So next, I would like to share with you a video the product we have displayed at the back is called hydrocerol. It's a chemical foaming additive. So the video will tell you the story behind. Hopefully works.
Welcome to Clariant's Hydrocerol for Extrusion Blow Molding Application Tutorial Video. The working principle of hydrocerol. As hydrocerol is a chemical foaming agent, you simply need to mix it with HDP resin and put into the hopper. At the feeding zone, hydrocerol starts melting into plastic. At the melting zone, the hydrocerol decomposes under heat and releases CO2 gas in the polymer. At the mixing zone, gas forms into fine-sized bubbles and distributes themselves into plastic melt to form a cell structure. When the cell structure becomes solid, you will have less density material. Secondly, to keep a good cell structure, you will need to reduce the blow pressure. If the blow pressure is too high, you will crash the bubble. Finally, since the material is swelling after the die head, some parts of the bottle will become very thick. At that time, you can adjust the Parison program to make the bottle wall evenly. One of the obvious benefits for you in using hydrocerol is less resin consumption due to an up to 10% lighter bottle. These are the following benefits when using our hydrocerol technology. It helps you to lower resin consumption, reduces packaging resources needed per unit produced. The end article remains recyclable. It improves the cycle time, which lowers the cost of the part to enable broader access and affordability. It enhances the aesthetic surface effect on multi-layer structures to reduce fuel consumption and costs in distribution logistics. Finally, the grade used is approved for food contact application. Our hydrocerol technology enables you to have a sustainable solution for your packaging needs.
The story about hydrocerol, a chemical foaming additive. How does it work and how does it contribute to sustainability? So Nalin, I think you understand where I come from with my questions. Yeah. So what is hydrocerol? So it's a chemical foaming agent. So just now I talked about all this mega trend and also the market need. And we take all this into consideration, the needs from the value chain. What happened in the value chain? They want to have less raw material usage, better cost efficiency, and all this is captured here. So consumable material reduction is one of the benefit because of the foaming effect. Less material is needed to produce the same type of bottle, and it has FDA. So this is beneficial for the consumer. For converter, they are looking into cycle time reductions. So also, overall, there's also potential investment saving. So for hydrocerol, chemical foaming agent, it can be used in different polymer processes. So it's very easy to use, usually in the bottle production or packaging container production, whether it's using EBM or ISBM. So there's usually a feeding hopper to handle the resin and also color master batches. So this CFA master batch, chemical foaming master batch hydrocerol, can be dosed in the same way by blending with the polymer using the same feeding system or using a side feeder system to feed into the extruder. So upon handling the extruder, the reaction will take place here. So you start with the plastification and then dispersion and then end up with a foam product. So this product can be used in injection molding, different kind of extrusion, sheet extrusion, film extrusion, profile extrusion. I have some sample there showing you all kinds of things can be formed using this product. And of course, blow molding. So in fact, it's not just a blowing agent because it's also a nucleation and also expand the plastic during the process. So in fact, using this solution, we have a lot of experience. Actually, Hydrocell contribute to our sustainability goals and also potentially this is your solution. It can be recycled easily. In fact, after decomposition, this CFA will become CO2 and water plus some inorganic material. It's something like what we are using in the kitchen during baking. I do foaming every weekend because I'm making my own cakes and my own bread. It's the same concept. It's safe to be used, have the FDA compliance. No worry when you are going to use a bottle to contain food or whatever. So because of the chemical reaction is very simple. And this inorganic material is very stable. In fact, it's very fine particles which can be used as a nucleating agent in further processing. Because a lot of people worry after foaming and less material is used, it may become a softer. But all this can be compensated by the inorganic material present, which being used as a nucleating agent that overcome all this shortage in the stiffness. And in the video, we show that we provide on-site technical support. This requires some optimization in the process. So if the density of the material is become very low after foaming, it might cause some separation by fractionation. So our experts present in the region at the country level, they usually go to the customer site to help them to do fine-tuning on the machine to get the right property and also right foam cell structure. If there's unreacted CFA in the regrind, it may cause some irregularity with the extrusion process. That means the bottle will not look nice. All these need some adjustment during the machine, but after a few rounds of trial, usually customers are once they understand the concept, they are able to handle everything by themselves. So where our focus area? So we, as I say, it can be used to form all kinds of things. So we take all this into consideration, market need, reduce packaging complexity, use less energy, because when less material is being used, that means less energy is needed for cooling down the plastic during the processing. And prolong shelf-life of goods and reduce material wastage. This is all this has been covered and easy to be recycled. So these are the market segments whereby we have successful cases. Example in health and nutrition, yogurt cups, noodle pots, and toiletry and cosmetic. We have jars and bottles. We have some bottles showcase at the back. And industrial packaging, pails, drums, and jerry cans, and industrial and food packaging, example, container, and lubricant oil containers and bottle. All this has been tried at the customer with great success. And some of them is in the process to commercializing it, and also some of them is already available in the shelf. In fact, some of the emerging countries, they are moving fast, much faster than all the developed countries. The local brands, they are aware they need to be getting faster and faster to differentiate themselves. And probably some of you, you are familiar with physical foaming. I'm also make a comparison here. What is chemical foaming as compared to physical foaming? In terms of the process, chemical foaming, I mentioned just now, is a chemical foaming agent. It's a chemistry that decompose into gaseous component like CO2 and water, etc. And it's being used like an additive as a nucleating agent. The dosing is very easy, just mix with the polymer or using a side feeder to feed into the extruder. And it can be available in different form, microgranular form or the standard granular size, same size as the polymer pellet. Generally, there's no investment because you can use existing machinery to handle this product. So different kind of processing method, extrusion or injection molding process can be used, and it's not flammable and toxic. So this is chemical foaming agent. This is a schematic diagram. So just blend the two raw material together or using a side feeding and feed into the extruder. And at the end, you get foam articles. Whereas in physical foaming, gases or low boiling liquids are used as a blowing agent. That means you need to inject gases or low boiling liquids to be used as a blowing agent. Example, what you can see nowadays in the market are the food tray made of polystyrene, insulation boards, PE profile. You can make extremely light foam as well. However, in this case, special machinery is used. And in some factory whereby they have space constraint, especially in developed country, the rental of the factory space is very costly. So you need to have this gadget here to handle all these low boiling liquids or gases to be injected into the extruder. So it involves some handling of gases, and of course the extrusion and injection molding process are the same, but there are additional investment here, and also space is needed to install this machinery next to the extruder for extrusion and also injection molding. So one of the technology is called Mucell technology. So let's compare the summary, what I have just talked about, the pros and cons. So for foaming agent is a solid substance, just like powder or granules, like what you have been handling. The polyethylene or polypropylene granules is the same way, same kind of form. So it's based on the decomposition in the extruder into CO2 and water. So it's based on the common machinery, easy dosing, and this is a benefit. As compared to physical foaming, as I said, you need to handle gases like N2, CO2, butane, and foaming agent is injected into as a fluid into the extruder. That requires some handling. So there will be higher gas loading as compared to here. Here is happened in situ in the extruder. So this could be one of the plus point. However, for in terms of the cost and also machinery, this has no additional investment. It's just an ongoing cost on the machine, existing machine you are using. However, the machinery part, investment part is is different from chemical foaming. It's involve complex machinery, need space to install the machine, and also there will be quite significant amount of initial investment. We have also investigated the cross section of the foam article. So both left and right of the picture is based on the PP long glass, 20% long glass fiber filled polypropylene. The delta P is the same 10%. However, when you look at the cross section of the article, here, based on chemical foaming, you have more homogeneous and smaller foam cell size structure. As compared to the right-hand side, the foam cell size is coarser. It's not as homogeneous as chemical foaming. There's a pipe at the back. Later you can have a look. It's a very homogeneous. We also do some microscopic tests. This is proven. So maybe look into some number calculation. So example in this case, the general bottle applications based on this polymer Marlex HDPE blow molding resins. Usually 1% master batch is used in this case, like to produce this white bottle. On top, they just put additional our product Hydrocerol 2225, dose at 1%. This is just like a master batch like this. So use a shutter blow molding machine, setting at this profile. So the end result is this is a successful finding. There's a rate reduction in this case by using 1% from 23 grams to 20 grams for the bottle weight. So there's a 12% rate reduction. So in terms of cycle time, because less material is being used, so the cooling time becomes shorter. So the cycle time becomes 16% shorter. And because of this chemical, it's not just a foaming agent, it's also a nucleating agent. So it passed the drop test. Also no leakages has been found. So next slide is talking about some numbers in terms of the cost benefit. So in this case, using HDP resin again, and using 1% of hydrocerol. In this case, you have 10% density reduction. All these are based on the actual trial on the customer's machine. So example, a market price of HDP is $1.30, and this is just an example of CFA cost, because we have different grade. Different grade will be having different pricing. Let's say in the customer's plant, they are using 1,000 tons of polymer per annum. So with 10% weight saving, they will use less polymer. So this is 10% weight reduction. So if no chemical foaming agent is used, the raw material cost is 1.3 million US dollar. So of course, chemical foaming agent is not free. They have to pay for it. Even though they pay for this amount of money, 70,000 US dollar for the chemical foaming agent, at the end, this is a net amount they are paying. So annually, there's a saving of 60,000 US dollar for the customer. So in other words, there's a weight reduction, and easy for handling because less material is being used. They do not have to keep so much inventory, and also easy because the bottles becomes lighter, easy for transportation. And more importantly, all this has FDA compliance. So, and also cycle time reduction. In fact, if we look at the productivity wise, the cycle time becomes shorter, means they can produce more bottle in 8 hours production shift operations. So there are two benefits here in terms of the money and also the productivity. So this is a sustainable solution. Let's talk about sustainability. Clariant is actually quite successful in sustainability. I think we are in the 3rd year in top ranking of the Dow Jones Sustainability Index. It's not easy to get there, but we have been successful and we are proud of it. So the background is in 2014, Clariant has joined the Chemical Industry Initiative, TFS, Together for Sustainability. And we are working jointly with a global sustainability player, with these members here. And we have this jointly operating global sustainability supplier assessment and audit program through independent experts. So this is one of the way it's not easy to get ourselves at this top ranking in the Dow Jones Sustainability Index. And this provides us a platform to enhance the Clariant supplier selection process and also to guarantee supply and also supplier risk management. And with this, we confirm that we are committed to be in product development and also customer service and support and also procurement in sustainability. So it's a very important demonstration that we are very committed to sustainability, and this product, hydrocerol, is a way that we can demonstrate that we are having a sustainable solution for the packaging industry. So this is the last slide. In summary, this morning my colleague Simon has already introduced to you about Clariant. We are a global company, but we are also locally present in almost every country in Asia. We have a production plant here in Thailand, in Vietnam, Singapore, whatever country you name it. Sometimes we have even more than one plant in a single country. So we are globally present with a strong local partnership, and we would like to work with you. We have a sustainable solution. We also have a team of product developer in R&D to develop a solution for the customer. And we constantly looking for opportunity where the market needs are, and also which link to the market trend. This lead to the innovation. We come up idea how to innovate further. We also focus on attractive market needs, capture the above average growth potential with key customer and also selected market segments. So we would like to work with you as a partner in this product development journey. So we are understanding the customer need because being an Asian, we know the needs here are different. Asia is a very big country. From country to country is different. So we are understanding what are the customer need and addressing the need by taking steps in the sustainable innovation. We also deliver the promise. This is one of the slogan in the company. This is one of the value. We continue to share ideas and develop Clariant chemistry to boost our sustainable solution. So HydroStraw is just one of them, which is one of the leading product. So this is my last slide. So we have a website whereby you can go in and understand more on HydroStraw. Okay, this is the end of my presentation.
Thank you, Sok-Meng Chan. Any questions on the floor?
If you ask me FDA or full approval in Southeast Asia, from my past experience, once you have FDA, it's easy. Example in China, whether it's get proof approval or not, they will use FDA as a reference. When if there's a FDA, that is an entering point. It's easy to do all this local testing. I'm not so much hands-on now. In my previous job when I was selling chemical, actually we deal a lot with this product safety. We also talk to the people in China on the regulation. They are trying to copy the procedure and also testing protocol in FDA. They were try to learn from us and how do you get the product classified as FDA approved. So I think there's no big change from that time until now. So Mr. Nali, maybe I ask you, since you see less material is being used, do you think the pressure requirement on EBM?
I think this is more or less injection molding and
extrusion blow molding.
Yeah. So that generally requires less than 10 bar basically.
Okay.
Yeah, 7 to 10 bar.
Thank you. So that's another benefit for the converter to save the pressure in your molding process. It's confirmed by one of the speakers here. Thank you.
Please. Oh.
In fact, Rogam has been trying. We have one customer which is making this in the similar industry as you. The specialty. I also came from polyolefin industry. Polyolefin, you can say there's a specialty segment, can be costly, and as a supplier, they want to keep the price. One way is to go for down gauging. Going for down gauging, they also have a concern whether the property will be different. So one way is to keep the same thickness, but introduce foaming agent in a middle layer, in a multi-layer film. So this one has been tried. It's not commercial yet, but they are still doing a further trial. They want to have even smaller foam cell size structure. So we are working with them. We jointly develop the product together. It's not transparent. Yeah. It's not transparent because you have a bubble inside and then you will scatter the light. Yeah. It will not be transparent, I have to tell you honestly.
Maybe if you can make it nano-sized bubbles, maybe then you can make it transparent. Very, very small bubbles.
It's not that easy, I will tell you honestly. I have some film sample in my office. It's translucent, not transparent. It's carbon dioxide maybe. Yeah, but it's a small amount. Carbon dioxide. All is being kept into the mold. If Nalin can help me to recycle the CO2 and go back to the system, that would be good.
You're also producing water in that reaction. So then the water will be trapped inside the material.
But you know there's a heating more than 200 degrees C. The water produced is minimal, not a big quantity. It's not huge amount of water being produced.
Okay. I see. But then for the you are creating bubbles, so the structural integrity may be different. If you make a film, the tension stability may be different. Right.
It's a good question. Just now I mentioned, it's not just a chemical foaming additive. It's at the same time because it has an inorganic material there. The inorganic material is a nucleating agent that compensate back on the loss of the stiffness of the material.
So you have done some tests and confirmed that's actually similar
actually
performance like without the foaming agent?
The brand owner has done the test.
Oh.
They have this top load test and whatever test they do stacking.
Okay.
So if it does not pass the test, they will not commercialize the bottle.
Okay. Very good.
That depends on the polymer and also the processing condition. We have done foaming using 0.4 to 0.5%. People can already see about 5 to 6% weight reduction. And in some of the sample at the back, the bottle at 0.8% CMA, they can get 15% weight reduction. That depends on the structure of the bottle and the polymer used. The orange color pipe there, they get about 20% weight reduction using 1.2% hydrocell. So it depends very much on the layer structure and also the raw material used and fine-tuning of the processing condition. So it's something very fun to play with, not just playing, but at the end apply it in your actual bottle. At the end we want to do good business together.
So if you have these sort of pores, you create sort of like a more open structure in the film. That means also that permeation, for example, of gases or water can be faster. So could it be that actually if you create a bottle with that sort of porous structure that you lose more gases or water through that structure?
This is a technology based on endothermic process and having a closed cell structure. It's not an open cell structure, it's just closed cell. In fact, it will improve the barrier property because the channel for the oxygen or water to go through is longer because it's closed cell. It's a longer path that it need to travel.
Okay.
Thank you.
So, there you go.
Yes, the barrier property is not compromised, put it this way. It's not actually done by us. The brand owner actually working with the converter to do it together.
Okay. So if there are no more questions, let's thank the speaker again.
Thank you.
Thank you. So with that, we conclude this session. I don't know whether you want to have a few words to conclude as organizer. Thank you.
Yes, I am.
Not far away from the office.
Is it?
Yeah, my card there.
Okay.
Simon is here. Later I will give you.
Yeah.
I thought it's a German company.
Yeah, it's a German company.
Oh, it's a German
Yeah,
company.
German. Kupfersohn is German.
I give you my card.
All right.
I'm not so good in all this hard.